let's jump right into it. Welcome to today's Explainer, where we're going to unpack something truly mind-bending. You know, whenever we look up at the night sky or think about the microscopic world of atoms, there's always that lingering question, right? Why are the rules exactly the way they are? Well, today we're literally looking at the mathematical source code of reality. We're diving into a fascinating analysis that suggests we can actually observe the cosmic pen writing the fate of matter and stars.
So for centuries, we've basically treated the constants of our universe, things like the speed of light, the mass of an electron, the distances between planets, as just arbitrary numbers. You know, we measure them in a lab, shrug our shoulders, and just say, well, I guess that's just the way the universe is. But what if that assumption is completely upside down? What if these constants aren't random lab measurements at all, but the absolutely inevitable results of a perfect, higher-dimensional calculation?
All right, let's look at Part 1, the blueprint. And that takes us right into Part 2, the divine filter.
To really wrap our heads around this blueprint, we kind of need to think of the universe as a massive factory turning pure theory into physical reality. Picture a luminous circle floating in a fifth dimension. This circle acts as a sort of boundary of perception, wrapping around a singularity, like the nucleus of an atom or the heart of a star. In this space, which the math specifically calls twistor space, you have infinite data from higher dimensions just swirling around. But it doesn't just spill into our 4D reality randomly. No way. It has to pass through what we're calling a divine filter, known mathematically as the Cauchy integral. Think of it like a giant cosmic oil press. It takes this overwhelming, infinite amount of complex data from higher dimensions and literally squeezes it, integrating it around a topological knot or singularity.
So, let's walk through this complex surgery step by step. First, all that chaotic, high-dimensional data enters the system. Second, it's forced through that topological knot, that Cauchy filter we just talked about. The data goes through what the math calls dimensional reduction, which basically ensures all the information entropy is transferred perfectly. And finally, step 3. What actually drips out at the tip of the pen into our four-dimensional world? A single, completely stable, eternal number. And that singular drip? That is exactly what we experience as a physical constant.
Now, this introduces a massive paradigm shift. It completely rewires our relationship with physics, because we're no longer looking at arbitrary dials that were just randomly spun at the dawn of time. Instead, we're looking at the inevitable geometric residue left over from higher dimensional math. The constants are just the exhaust, the necessary leftovers of a perfect calculation dropping right into our universe.
Which brings us to Part 3, the sacred residue. Okay, so if these constants are just mathematically distilled residues, what do they actually look like in our physical world? Take a look at this number, 0.3946 astronomical units. This represents a very specific planetary distance. It's closely related to the orbital distance of Mercury from the Sun. But as the source analysis reveals, this isn't just some random rock floating at a random distance. By using specific scaling formulas that connect higher dimensional lengths to our standard SI units, this exact number links directly to the foundational structure of atoms, specifically the Bohr radius. It scales perfectly. But you've got to wonder, where does this highly specific number even come from?
Well, imagine taking a complex, multi-dimensional piece of paper, specifically a geometric shape called an icosahedron, which is famous for its incredible symmetry. Now imagine folding it to its absolute geometric limits in a higher dimension and then unfolding it back into our flat 4D reality. The geometric surface tension reaches an equilibrium and it leaves behind a permanent crease. That base crease, that golden fraction left over, it's exactly 0.3946 AU. It is literally the first coordinate where the math allows matter to stabilize into an orbit. How wild is that?
This paints such a perfect contrast. On one hand, we have the old view of random measurements, where we just assume a planet happened to fall into a certain orbit, or an electron just happened to have a specific radius. But on the other hand, we have this new paradigm, geometric residue. It's an exact, completely formula-driven framework. The macro, like our planets, and the micro, like the Rydberg energy states of an atom, are perfectly linked by the exact same geometric folding. It's absolutely beautiful when you think about it.
Let's move on to Part 4, information pressure. So, let's push our view out to the absolute outer edge of reality for a second to examine the exhaust of this cosmic factory. This analysis offers a genuinely breathtaking redefinition of dark energy. You see, traditional science usually treats dark energy as some mysterious, invisible substance that's just pushing the universe apart. But the math here suggests something entirely different. It proposes that dark energy isn't a mysterious substance at all, but rather computing heat,
literally the physical byproduct of the universe acting as a giant 12-dimensional calculator.
Let's look at how this builds mathematically. The source analysis uses something called the Dirichlet-Eta function, and it arrives at this very specific mathematical constant, the natural logarithm of 2, or ln2. So why is this number so crucial? Well, in information theory, ln2 represents exactly 1 bit of information. And guys, this is not a coincidence. This 1 bit of data is sitting right at the absolute boundary of our universe.
This brings the whole holographic principle into play. Imagine our entire universe is wrapped in a super thin membrane of information. At every single point on this boundary, the cosmic code is desperately trying to process binary data, a 0 or a 1. And the sheer effort, the physical action of processing this immense amount of binary data across the entire surface area of the universe creates what's known as information pressure. That pressure, that computing heat from processing the code, is literally what is forcing the universe to expand. Dark energy is, quite simply, just the heat of a cosmic hard drive spinning.
Now, for part 5, the universe's signature. We've covered some incredible ground today, from microscopic geometry all the way to the edge of the universe. So bringing this whole factory of reality narrative together, here are the 3 transformative takeaways we've unpacked. First, the Cauchy integral is the divine filter, that mathematical funnel distilling infinite high-dimensional chaos into our stable 4D reality. Second, the distances of orbits and atoms aren't random. They are the literal physical folded creases left over from higher dimensional geometry. And third, the expansion of the universe, dark energy, is simply the 1-bit processing heat of this massive cosmic calculator doing its job.
For so long, we've thought of mathematics as just a language that humans invented to describe what we see around us. But this analysis flips that idea completely on its head. Mathematics isn't just a descriptive tool. It is the signature on the universe's work order. Every single time a scientist takes a measurement in a lab, every time they calculate the mass of a particle or the distance of a star, they aren't just recording a random fact. No, they are literally reading the mathematical residue, the divine ink, if you will, left behind by the ultimate calculation of existence.
Which leaves us with a final, pretty thrilling thought directly from the source material. We now see that the physical constants of space, matter, and energy are just extracted geometric residues. But what about the 4th dimension? If these numbers dictate space, how do they assemble to build the actual mechanism of time itself? Now that is the next great frontier of this theory. Thank you so much for joining me on this explainer today. Keep questioning, keep learning, and I'll see you in the next one.